Hello, welcome to OmegaCodex. Let's kick off things today with a very familiar story. Picture this. You are a dedicated developer pouring your heart and soul into crafting an amazing web application. Days turn into nights and you are lost in the lines of code, wrestling with frameworks and battling with compatibility issues. It's like trying to navigate a complex maze without a map, isn't it? Well, we all have been there. That's where .NET Aspire comes in. It's like that friendly chef who hands you a well-structured recipe, making your journey through web development smoother, faster, and most importantly, enjoyable. So, what exactly is .NET Aspire? .NET Aspire is like a toolbox filled with powerful tools for web developers. It's a stack of curated set of components for service discovery, telemetry, resilience, and health checks by default. It also provides a local development experience that makes it easy to discover, acquire, and configure essential dependencies for cloud-native apps. In this video, we'll get a grasp of what Aspire offers and go through a sample project to understand it better. So let's dive in and get started. Before we dive deeper, let's understand the landscape. In today's cloud-native world, applications are no longer monolithic giants. Instead, they consist of small interconnected services that consume various cloud services like databases, messaging, and caching. And that's where the challenge begins, orchestrating these distributed applications across multiple nodes, ensuring that they communicate seamlessly over network boundaries in a cloud-native environment. We all have been there, struggling with complex configurations and compatibility issues. So why should you be excited about .NET Aspire? Let's break it down. .NET Aspire is designed to enhance your experience of building .NET Cloud Native apps by providing a consistent set of tools and patterns. First, it handles orchestration. What does that mean in the world of .NET Aspire? Orchestration refers to the coordination and management of various elements within the cloud native app. .NET Aspire simplifies the configuration and interconnection of different parts of your app. It provides abstraction for managing service discovery, environment variables, and container configurations, abstracting away the low-level implementation details. For instance, with .NET Aspire, you can easily specify .NET projects, containers, executables that make up your application. .NET Aspire abstracts the complexity, ensuring consistent setup patterns across multiple apps and components. We'll look into it when we will get to our sample project with .NET Aspire. Next are the .NET Aspire components, the building blocks that make the cloud-native development a breeze. .NET Aspire components are NuGet packages designed to simplify connections to popular services and platforms. They handle cloud-native concerns through standardized configuration patterns. These components are designed to work seamlessly with .NET Aspire. They automatically flow their configurations through dependencies based on .NET project and package references. So if one component refers another, the required configurations are inherited, allowing them to communicate effortlessly. For example, with .NET Aspire Service Bus component, you can easily register a Service Bus client as a singleton in DI container, configure it, and enable health checks and telemetry specific to Azure Service Bus. Lastly, let's talk about the project templates and tooling, the secret sauce that accelerates your .NET Aspire journey. .NET Aspire apps follow a standardized structure based on default project templates. To kickstart your journey, .NET Aspire provides two starter templates. The first is a basic template with essentials for you to build upon, while the second one includes pre-configured UI and API projects ready for service discovery. So now let's go ahead and create our project and understand more about Aspire. For .NET Aspire, we need to install some tooling and we'll need to do some setup. So as you can see in the documentation here, to install .NET Aspire, we will need .NET 8 because that's the version where .NET Aspire is introduced. And then we will also need .NET Aspire workload on Docker Desktop and Visual Studio 2022 preview. So you can go to the .NET.microsoft.com and download .NET 8.0. And if you want to install the .NET or the Visual Studio preview, you can go to visualstudio.microsoft.com on the link shown here and download the preview version. You can also download Docker Desktop from the Docker website. So if you're new to Docker Desktop, you can watch the video mentioned here above, where I have explained how to work with Docker Desktop along with Visual Studio for your local development environment. So I have .NET 8 already installed on my machine. I'll not be using the preview version. I'll be using the general available version, Visual Studio 2022, the latest version, whichever is available. By the time you're watching this video, .NET Aspire could be part of the general available version. But for now, it is part of preview. But we will see how in the normal edition we can install Aspire using the .NET CLI. For that, let's open the terminal and run .NET workload update. So this will update the existing workloads. The next command we have to run is .NET workload install Aspire. So I already have the workload installed, so I'll get this message. But if you don't have it installed, then it will install it. Now with this Aspire installed, we will also have the starter templates installed as part of Aspire. So to check that, we can run the command .NET new list Aspire. So we have two starter templates. So one is Aspire application, which will just give you the basic projects which you need to get started with Aspire. Then you have the starter application, where you will have a web API and also a web application as part of the project, and you can work with a complete application. Now, if you have Visual Studio 2022 preview installed, then you can also see those templates in Visual Studio. But since I don't have the preview installed, I'll be creating the project from the CLI itself. So for that, let's run .NET new, and I'll use the short name Aspire starter. That's the project we'll create. And I'll also want to use Redis cache. So this is an option available with the project template, where it will also add the dependency for Redis cache. And as output, I want Aspire starter sample. Now the project is created. Let's open it in Visual Studio. Now the solution is opened. Let's have a quick look on the solution explorer. So we have 4 projects here. One is the web application, which is a Blazor project. And then we have the API service, and we have 2 more projects. One is app host and another one is service default. So let's open the app host project, and each of these projects will play an important role in the composition of your application. So if we check the project template of app host, you can see that this flag is set to true, which is that it is an Aspire host project. So this project is responsible for acting as an orchestrator, and when you set this flag, that is what this indicates. Now let's just expand this and look at program.cs. So we see a similar setup like we see with a web API or a .NET web application, where we usually have a web application.create builder, a code, something like that. But here it is distributed application.create builder. So this one creates an instance of iDistributed application builder, and then we are adding the dependency of Redis, and we are naming it as cache. So the name can be anything, and as it mentions, this adds a Redis container to your application model, and the default image is Redis and the tag is latest. Now we are adding the API service project to this builder by calling add project. Press on the project namespace. You can see that it lists all the 4 projects which are available as part of the solution. So here it has selected the API service and it has named it as API service. Again, it's a name given to easily identify the project, and it can be used when referencing the project. After that, we are adding our web project with the name as web frontend, and here we are adding these two as references. So our web project is actually referring or using the cache as well as the API service. So these are two dependent services for the web app project. So this with reference API is one of the fundamental APIs of Aspire, which injects either a service discovery information or a connection string configuration into the project when you are adding it to the application model. Like for example, here in cache, it will be adding the connection string for the cache, but with reference to the project, it will be adding the service discovery information for this project. So we don't have to worry about the URL of API and setting it up in the project with configuration settings. It is automatically taken care by this setup. Now let's go to another project, which is service default. So again, here we see that there is a new tag in project group, which is Aspire shared project. What this project would do is that it will ensure that all dependent services have the same resiliency, service discovery, and telemetry configurations for all the projects which you are including as part of your application. So these can be a service defaults, and it can be applied to all the applications. So let's just go to this extension method, and here we can see it has implemented few methods by default. In add service default, setting up the open telemetry, we're adding default health checks, adding service discovery, and then configuring HTTP client defaults. And if you come down, you can see it has implemented some common settings which can be used for the applications. Now, if we come to the web project and look at the web API client, so this is just a simple class which is using the HTTP client, and then we are calling the weather forecast endpoint from this HTTP client, but there is no mention of any base URLs which it would be connecting to in this class. So the HTTP client here is configured to use the service discovery, and we can look at the program.cs to see how this works. So in the program.cs of the web application, it is calling the service default, so which was part of our service default project, and it's the same extension method being called here to set up all service discovery and other default configurations. And then it's calling builder.redis output cache, and the connection string or the name of the cache is same which was used in the app host project. And after that, we are adding HTTP client, which is the class which is part of the project, that is weather API client. And here the base address is set up to be called as http://API service. So if you see, it's the same name which was used in this app host project. So the same API service is used here as the naming for the service, and we don't have to worry about what the actual endpoint of that service would be. To sum it up, in the web project, it is calling the add service default to set up the defaults, shared defaults for the application. Then it is using the add redis output cache with the same name which was used in the app host project. So it is essentially using the same connection string which would eventually be set up when we run the application. And then we are adding an HTTP client, and we are configuring the base address to API service. So it's the same name which we have provided in the app host, and the service discovery part of it is already automatically taken care by Aspire. Now, if we come to program.cs in the API service, we can again find the builder.addService default to apply the same defaults for the API project as well. And I think pretty much everything else is self-explanatory. It is just a minimal API project which is randomly sending some weather forecast. So we wouldn't be doing any changes to it. We'll just run it and see how this works out. if you have enjoyed the journey with me so far in this video, don't forget to like the video and please hit the subscribe button so that you can join the community. Remember, your likes and subscriptions do make a big difference. So now let's run this project and see what it offers. Before running the project, make sure that your Docker desktop is running. Otherwise, you may face issues when you start this project because it uses the Redis cache container. So you can see that it has started Redis container on Docker and our project has started running. So now if you see, it didn't start any web app or any browser when we started this app, but we can go to this link. We'll just do a control click and we'll check what it opens. Okay, so what we have here is our Aspire dashboard, and this is something which is available on the local development environment to ease up your development experience, to make it smoother and more insightful. So here we can see that there are 3 resources which are part of our project. One is the container cache, which we had added, and we have 2 projects. One is the web front end and one is the API service. So if we click on this endpoints, so these are for web front end, it has started on localhost 5247, and web API has started on 5391. And if you see, we didn't do any configuration setups for any of those. We just did, what we did was to add the dependencies in the app host project. So this is the sample app, which is part of the starter template. And if we go to the weather tab, you can see that it is calling the web API endpoint. If I keep on clicking, it loads the weather, but it is loading the same data as and now the data has changed. We can have a look. So now you see it is changed. Again, it's calling, but it's not changing. But then now it's changed. So if you remember, we had added the output cache, and it is caching the data which is getting from the API, and it's not making that call until the cache expires. So everything is being automatically managed as part of the setup. Now let's come back to dashboard and have a look into what we have here. So if we go to the resource types here on the filter, we can see that it would show projects, containers, and executables. So any projects that are part of your web application as part of your solution would show up here. Any containers which you add, like Redis or any other, say MS SQL or any other container, if you add, that would show up here. And also any executable dependencies, if you have, that can also be added and it would show up here. So this shows what all resources that are part of your whole application model. We can see there is this environment column which mentions the environment variables. So let's have a look into that, and you can see that all the setup is being automatically done by Aspire. So we have the ASP.NET Core environment, we have the cache, which is the cache setup on Docker. Then there are some other properties for OpenTelemetry, and then we have the API service endpoint, which was added by Aspire itself. And what I was mentioning also is earlier was that this provides you a common pattern to set up the configurations, and using those patterns, it is orchestrating different components for your application and is able to interact with different components. If we look at the environment variable of API service, I think there wouldn't be much here because we didn't have any dependencies. The only thing we had was the environment, which it automatically sets. So the dashboard also provides, essential details about monitoring. So you can also go through the logs for each of the application. So you can see the calls which happened. So let's say we come and click here again, and we should see a weather forecast call which happened on the backend side. Similarly, the same logs are, I think, available as a structured log, and it becomes a more readable version of the log. Can also have a look into the traces. So this would help you understand the performance of the application, how much duration it is taking for all of these calls, and how it is performing. And the last one is metrics. .NET Aspire automatically configures the metrics, which you can check. So the number of requests, active connections, and there are many more metrics available. You can pick each of the resource and then check the requests. So this will help you gauge your app's performance and monitor its vital signs. So as I mentioned, this dashboard is still available only as part of the local development. So this thread here talks about how we can make it available, or is it available for deploying to servers, and that is something which is still under works, and I think the .NET team is still trying to figure out how to make it easily deployable. But as of now, it is only available for local development, and it's pretty good. You can get easily started with your project, and have look into different aspects of it. We have just scratched the surface of what Aspire has to offer. We have delved into orchestration and learned about .NET Aspire components that simplifies cloud native development. We have also seen the project templates and the tooling that makes our journey smoother. Our adventure with .NET Aspire is far from over. There is a world of possibilities waiting to be explored. Stay tuned for more in-depth content in upcoming videos. Meanwhile, check out the references in the video description for a deeper dive into the official documentation. If this video was beneficial to you, please consider giving it a thumbs up, and don't forget to subscribe to OmegaCodex if you haven't already done it. Continue coding, discovering and soaring to new heights with .NET Aspire. Until next time, keep coding smart and keep innovating. Adios.